Hello everyone, welcome back to the next topic in C programming language. In this particular video, we are going to have a look at topic called as pointers. The coverage in this particular video is we are going to have a look at introduction to pointers followed by the definition. Then we will have a quick overview of the underlying concepts of pointers. And then we move on to see the two important operators on which the entire world of pointers actually lie. Pointers, pointers, pointers. Pointers is normally considered as one of the most difficult and most confusing topic in the world of C, and that's what I have, come across. Quite majority of the students who are exposed to this particular topic called as pointers for the first time, and then after trying to understand it, they still end up telling that it is confusing topic. Now, this impression, that's my opinion actually. This impression about pointers is mainly due to lack of systematic understanding of the concept. Majority of the audience I have seen, they study this particular topic from the academics point of view. But let me tell you that it's extremely important for anybody who wants to join, make a career in the software industry. The most of the placement questions, the interview questions and stuffs like that, they emphasize more on this particular topic pointers. My personal opinion is unless and until you don't master pointers, unless and until you don't have grip on pointers, right, you will never master and you will never become expert in C programming language. So, before we proceed, let us slightly have a twist about how best we can give a trailer to the topic called as pointers. I call it as eye of the storm, right? Whatever I'm going to tell you in the next two slides that has got nothing to do with the technical aspect, but yes, it will just lay the path for us to understand the pointers in a much better fashion. Speed, the jet age. It's the world of instant coffees and 2-minute noodles, 2-second banking, 10-second lunches. You all agree it's the world of rushers today. Everything from careers to holidays take a fast track today. And it was in this environment that C was born. Let's hold it down for a second and check its amazing speed. Pointers, the soul of C, the substance that gives the language its body. That's what I told you earlier. You cannot explore the amazing breadth of C until you have mastered pointers. Let me reiterate, you cannot explore the amazing breadth of C until you have mastered pointers. So, get ready to systematically analyze and understand the concept of pointers in such a way that you would never stand confused again. That's what I would like to. Really? That should be your expression once I go through this particular slide. Now, what is this? Pointers are one of the most confusing and challenging parts of C, in my opinion, and also the opinion of majority of the people I've come across. Despite having experience in pointers, it is still sometimes lands up confusing. And every day you find new stuffs that you can do in this particular pointers. Actually, pointers are an extremely powerful programming tool. It plays a vital role in C language. They are easy and fun to learn. Definitely you will agree, as and when we proceed further, that pointers in C are easy and fun to learn. Some C programming tasks are performed more easily with the pointers, right? Such as dynamic memory allocation, right? This is one important concept in the field of pointers, where in depth you are going to study in the upcoming semester subjects called as data structure. That dynamic memory allocation cannot be performed without using pointers. Apart from that, pointers are prevalent throughout the language, And it is more important to understand them in order to take advantage of many of the features that exist in the language. They can make some things much easier, help improve your efficiency, means improve your program's efficiency, and even allow you to handle unlimited amounts of data. So the bottom line is you cannot be a perfect C programmer without the knowledge of pointer. So you should have a good sound knowledge of pointers. So it becomes necessary to learn pointers, right? In a nutshell, I would tell you this, that it is extremely important to learn pointers and master it, which will enable you to become a perfect C programmer. So let us move on to the definition. What is a pointer actually? Right? Let me spill out the secret. If you try to recollect any programs that you have done so far, right, you have always used ampersand symbol in one of the operations, in one of the IO operations, right? That is input operations. So if you try to recollect your syntax of so-called input function, that is scanf, particularly, which had two parameters. The one was format specification and the second one was list of variables. Am I right? Now, in the list of variables, the variables were actually preceded by ampersand. But sometimes the doubt would have definitely come with that when IO operations goes together, why the ampersand is present only in input operation and why not output operation, right? The answer to that question lies in this particular slide, right? So let's look at the definition of what is a pointer. Pointers are nothing but a variable that contains an address which is location of another variable in memory. Looks to be slightly confusing. So let's look at a simple definition of a pointer. Even though the above one is also a definition, let me put it in a simple term that variables that hold memory addresses are called as pointers. Okay, so I repeat once again, variables that hold memory addresses are called as pointers. Now, reasons for using a pointer. So these are the following reasons. Enables us to access a variable that is defined outside the function. Definitely we are going to look at this down the line. More efficient in handling data tables. Reduces the length and complexity of the program. Increases the speed of execution. Fifth one, use of pointer array to character strings results in the saving of data storage space in the memory. We are going to look at this particular fifth point at the fag end of this particular topic. And the last one is to do systems level programming where memory addresses are useful. So there are quite good number of reasons what actually makes a programmer to land up using a pointer. Let us look at the underlying concepts of pointers and then we go into the deeper aspect. Pointers are built on the three underlying concepts, right? Now, which are those? The first one is called as pointer constants. The second one is called as pointer values. And the third one is called as pointer variables. So these are the three underlying concepts on which the entire world of pointers is built. Now, what is pointer constants? Memory address within a computer are referred to as pointer constants. We cannot change them. That is because they are like house numbers. Okay. Next, pointer values. We cannot save the value of a memory address directly. We can only obtain the value through the variable stored there using ampersand operator, which we call it as address operator. And thus, the value that we obtain through that is known as pointer values. The third concept of pointer is pointer variables. What it says, once we have a pointer value, it can be stored into another variable. The variable that contains a pointer value is actually called as pointer variable. Now, let us look at the declaration and initialization part of pointer variables. So as usual, you have a syntax in front of you. the syntax of pointer declaration is you have a data type followed by star, which says it is a pointer, and followed by the name of the variable. Example is int space star p. So this says that you are trying to declare a pointer, right? So the interpretation of this statement, int star p, means you are declaring variable p as a pointer variable that points to an integer data type. Okay, p is a pointer variable that points to an integer data type. So you have int star p, and then you have, let us say, int q, right? Now these are the two declaration statements, right? Int q is a normal declaration statement. And then what I'm doing in the next line is I'm just trying to say p is equal to ampersand of q. Okay, p is equal to ampersand of q, which is nothing but the initialization part. And then this also is allowed, where you can club the stuffs and you say int star p is equal to ampersand of q, where again p is nothing but a pointer variable which points to integer data type. Now let us look at pointer as a variable. Now this is using ampersand operator. Okay, using ampersand operator, and this will give you the answer to the last long, the question that was there in your mind from long time, for a very long time, I mean, that why we never used ampersand operator in printf statement. Okay, so pointer as a variable is totally based on the ampersand operator, right? Now let us have a look at a simple example. I have a variable q which has got its value as 179, right? It's just an ordinary integer variable. And then I have a simple initialization statement which says p is equal to ampersand of q, right? P is equal to ampersand of q. Now let us look at how this is actually stored in the memory, right? I just have two variables, one variable q which has got a value that is 179, and p is equal to ampersand of q. Okay, so how does the memory representation look like? So this is my q, right? Now watch out carefully. The value of q is 179, as we have seen in the earlier slide. So 179 is the data or value of q, and there is something called as 5000 which is slightly written to the left of q. Now this is the place where variable q is stored in your memory. So this 5000 is actually called as address, where the variable q is stored, right? And that is what I said, that address is a unique number which cannot be changed. As I told earlier, that it is like your house number. Okay, now the only fundamental difference between the real life house number and the address of the variable in programming language is your house number is it's fixed, right? It won't get changed, right? So whenever somebody asks you to give your residence address, the house number will still remain same. Okay, but then that may not be true. In fact, that is not true, actually speaking, in the programming language like C, right? Now for example, what happens, right? Now the variable q is stored at address 5000, right? Now tomorrow when I run this particular program, right, variable q might be stored somewhere else, right? We do not know, because address where a variable will be stored is not in the hands of the programmer. Okay, so even this 5000 is not in the hands of a programmer. I'm just assuming that at this junction, at this given point of time, variable q is stored in address 5000. Okay, now we also have another variable p. Recollect it? We have p is equal to ampersand of q. So it looks like this. Now when you say p is equal to ampersand of q, it means that, watch out, when you say p is equal to ampersand of q, it means that assign the address of q to p. That is what is ampersand. Ampersand means address operator, right? Ampersand means address operator, right? So p is equal to ampersand q tells that assign the address of q to p. Now what is address of q in our example? It is 5000, right? So what happens? P gets the value as 5000. you see 5000 is written inside the box. So this 5000 is actually nothing but address of Q. And the statement P is equal to ampersand of Q will assign the address of Q, which is 5000, to P. And hence here what happens, right, in the second box, 5000 becomes the value of P. But you agree that P itself is a variable. So it should also be stored in some or the other memory space, memory address. So I have assumed that variable P at this point of time is stored in address 5048. Got the point? So let me once again reiterate this particular slide. I have two variables, P and Q. Value of Q is 179. Variable Q is stored in address 5000. P is equal to ampersand of Q will assign the value of will assign the address of Q to variable P. So P becomes 5000. Since P is a variable, it will also be stored at some particular address location. So the address of P is 5048. Okay. Now what we do is we just try to convert this particular representation in the form of a code so that you understand better. The only thing you need to understand from that code is whatever the address of Q is given, or you get the output as address of Q, the same address of Q will go and sit as value of P. Okay, so let us have a detailed code representation of this particular memory map. So let me take you to the online C compiler. That is always the best way to check what we are doing is correct. So I always prefer this compiler. So let me go and then okay, so I have my preprocessor directive, and then okay, I don't need this. Okay, so I'll have int P comma Q. Okay, so that's what I have, and then I say Q is equal to 179. That's what we have seen in the PowerPoint slide. And then P is equal to ampersand of Q. And then what I do is I say value of Q is equal to percentage D, and then I say Q. Let me go with one more printf statement. Address of Q is equal to, right? Now watch out carefully. That is where I have used my ampersand operator, right? So this ampersand operator in line number 8 will give me the address where actually Q is stored, right? So now you recollect that ampersand operator, we are using it for the first time in printf statement. Okay, so that is the prime reason we did not use ampersand so far in our academic discussion, right? Then what I do is I just do the same stuff for variable P. So I just put it here. Now I just say sorry. So it's a value of P is equal to, this is my P, and then address where P is stored. So it is ampersand of P. Okay, so this is how I land up getting. Let us check whether this code works. Okay, let's not bother much about warning. So this is what it is, right? Now have a look at it. Value of Q is 179. There's no doubt about it. Now look at the address of Q. Okay, so don't bother much about such a large number, right? That is not our problem, right? So address of Q. So this is the address of Q. So this is the address where variable Q is stored, whose value is 179, right? Now we have seen that we have the statement P is equal to ampersand of Q, where we said it will assign the address of Q to P. What is the address of Q? This one, right? The last four digits is 6076. Now that will be stored as value to the variable p. So that is why you see this output, value of p is equal to something. So this is value of p, which is actually nothing but the address of q. Got it? So the address of q and value of p, these two will be same for simple reason p is equal to ampersand of q in line number 6. And we also have seen or made a statement that p itself is a variable which has to be stored somewhere, and hence the address of p is nothing but this one, right? So p is also a variable which is stored at this particular point of time in this particular address, right? So that is how basically the ampersand operator works in C programming language. So let us proceed, and even though we make use of ampersand operator in C, there are certain places where as a programmer you should keep, you cannot use ampersand operator. Okay, just because India is a democratic country, it does not mean that you use ampersand operator wherever you want it, right? Okay, so the first thing is ampersand of 125. You cannot use ampersand operator pointing at a particular constant. The second, int x of 10. You cannot use ampersand operator pointing at an array name where you say ampersand x and x is nothing but a array name, right? You cannot do it because if you recollect your array topic, I have made a statement that whenever you refer an array, you always get the base address. That is the address where the starting element of an array is stored. And the last one is you cannot use ampersand operator pointing at a particular expression because suppose for example if the value of x and y is is something, some constant, so addition of both will again result into a constant, and hence what happens, the third illegal use of ampersand operator is more or less equal to the first illegal operator, that is pointing at constant. So these are three illegal use of ampersand operator. Now, let us have a look at the other operator available in C. As I told you that the entire world of C pointers is basically, it basically stands on two operators called as ampersand and star operator, which is called as asterisk operator. Okay. Now, what is the fundamental difference? On one hand, the ampersand operator gives you the address where variable is stored. On the other hand, the asterisk operator gives you value at that particular address. Okay, so let us see that slowly. Nothing to worry about it. So have a look at it. I have a variable I whose value is 3 and it is stored at address 6485. Now, this is what I get it. Ampersand of I is 6485. You agree? Address of I is nothing but 6485. Value of I is 3. Now, star of ampersand of I. Okay, so listen carefully. Star of ampersand of I. Now, what is ampersand of I? 6485. And then that gets reduced to star of 6485, this particular one, right? So this is star of ampersand of I. Ampersand of I is 6485 and this reduces to star of 6485. Now what is star 6485? It tells that go to address 6485 and pick up the value, right? Star 6485 means go to address 6485 and pick up the value. That is why it is called as value at address operator, right? So what is the value at 6485? 3 itself. So star of ampersand of I is 3, and hence I make the statement that star of ampersand of any variable is variable itself. You agree? Star of ampersand of any variable is variable itself. That's why I have written star of ampersand of I is same as I. So we can also have j is equal to ampersand of I, where j is not an ordinary variable. It contains the address of another variable. Okay, it contains the address of another variable. So what we do is, in order to understand this concept of star in a much better fashion, we shift our focus from the discussion, from the PowerPoint discussion, to the online compiler. So let me take you to the online compiler and let us try to see how basically star works in C language. Okay, so let me have a code. I will say I slightly change the variables. So I have two variables called as a and b with the value as 10 and 20. So I don't need those things. Now what I say is, I say value of a is equal to percentage d, and address, let it be percentage d. I'll make it as u. So a comma ampersand of a. Okay, a comma ampersand of a. Similarly, what I do is, I will just copy the same stuff and then I will use it for b, and then I say value of b is equal to percentage d, and address is also ampersand of b. So this is how I get both this. Now what I say, printing value of variable through asterisk. Okay, so I just put this particular statement that I'm trying to print the value of variables through star operator. That's what it means, right? Through star operator. So I just say value of a is equal to, watch out carefully what I'm going to do. I'm going to say star of ampersand of a. Okay, star of ampersand of a. And similarly, I say value of b is equal to percentage d, and then I say star of ampersand of b. Okay, so just have a look at it and let us see whether this program works. Okay, so I have the code in front of me, so let me run it once again and then let me see what is the output that I'm going to get it. Uh, yeah, that's fine. So watch out carefully. Value of a is 10 and address is this one. Value of b is 20 and address is this one. Right now, that is okay. That's fine. We are comfortable with these two. But then now we are trying to print the value, printing the value of variable through asterisk. So again, you see value of a is 10 and value of b is 20. So what it says is value of a. Now this is the reason we are getting the value of a as 10, star of ampersand of a, right? So through this star, which is asterisk operator, I'm trying to get the value of a as 10 and b as 20, right? So that is how basically these two operators work in C programming language. The ampersand operator, which will give you the address, and the star operator, which will give you value at that particular address. Okay, so once again, from the satisfaction point of view, let me run the program. So this is what you see. Okay, so value of a is 10, b is 20, and again you are getting the both here actually. Okay, so let me also run one more program for you. So I have this, I won't change. I just say x equal to 25, and then I have a pointer variable in star of ptr. So ptr is a pointer variable of integer data type, and then I just say ptr is equal to ampersand of x, and then I have a printf statement which will print let me make it a simple printf, x equal to %d, and then let me also have one more printf where I will say value of ptr, where I say star ptr is equal to %d. Okay, right? So let us see the output of this particular program. Okay, so the output is x equal to 25 and star ptr equal to 25, right? So it's a self-explanatory, right? So you have x equal to 25 and star ptr is a pointer variable, ptr is equal to ampersand of x. So what happens is, this I don't think line number 7 I need to explain you, but let us focus on line number 8. And in line number 8, you are actually trying to print star ptr. So what is ptr? Ptr is ampersand of x, and hence what happens? This star ptr actually looks like star ampersand of x. Okay, sorry, star ampersand of x. Right? Now we have already seen star of ampersand of any variable is variable itself, and hence star ampersand x is nothing but x. Okay, star ampersand x is nothing but x. What's the value of x? 25. Okay, so that is the prime reason you get the output as star ptr equal to 25. So that's what we have seen. Have a look at this particular code. Now I have variable I as 3, address of I is 6485, address of j is 3276, but j is ampersand of I. So address of I goes and sits to j. So j is 6485. And I have a couple of declaration statements. The first one is int I equal to 3. The second one is int star j, which is nothing but j is a pointer variable. And then you have a statement called as j is equal to ampersand of I. So let us look at the implication of this. What will be the following result? The first one, ampersand of I. What is address of I? 6485. Next, what is the value of j? 6485. Ampersand of j, the address where j is stored, 3276. The next set of 3. What's the value of I? 3. Straightforward. Star of ampersand of I. What is address of I? 6485. And star of 6485 is 3. Okay. And then next. And moreover, the fifth one can also be interpreted as star of ampersand of any variable is variable itself. Right. So that is another way of interpretation. So the value, the result of point number 5 is 3. Point number 6, star j. What is the value of j? 6485. So it becomes star of 6485. That means what? Go to address 6485 and fetch or pick the value there. What is the value at 6485? 3. So the result for point number 6 is also 3. Okay. As a matter of fact, the result of the last 3 statements, right? I, star of ampersand of I, and star j, correct? Both are, all the three results are actually 3 itself. Okay. So this is the concept hidden behind ampersand and star operator.